This session is on hydroplate theory's assumptions and initial conditions. It's important to point out that every theory has underlying assumptions. Assumptions aren't really part of the theory, but they do act like a foundation upon which a theory is built. First, I'm going to highlight three of hydroplate theory's theological or philosophical assumptions. The first is that the Bible's account of six-day creation is true. So hydroplate theory has all the standard young Earth assumptions, such as evolution being false, radiometric dating showing us something other than the true age of the Earth, fossils having been created by the flood, etc. Second is that when God said his creation was very good, this implies that all of creation was designed not to harm humans. Therefore, before the fall, there would not have been any volcanoes, lava, earthquakes, lightning storms, hail, hurricanes, tornadoes, tsunamis, avalanches, mudslides, radioactivity, or asteroids and meteors. So all of these things might be scientifically interesting, but they're dangerous and they pose a threat to humans. So we must assume they can't have existed before the fall. Hydroplate theory is the only flood theory that believes that comets, asteroids, and meteors were not part of the created solar system. So this is a very important point. All of the big creation science groups will say that comets, asteroids, and meteors were made probably on day 4, along with the rest of the heavenly bodies. However, comets and meteors have always been considered dangerous. Before the 20th century, comets were seen as warning signs of impending doom. Our word disaster means disaster, bad star, and refers to comets and meteors. They probably had this reputation because people saw the damage that they can cause when they strike the Earth. Here's a photo of the Hoba meteorite, which is the largest meteorite ever discovered, and it's a good thing that it fell in a remote part of Namibia and not on a village. Here it is again as it looks now, having been turned into a tourist attraction. Here's a photo from 1908 showing trees that were destroyed by a stony meteor that exploded in the atmosphere a few miles above the Earth. 80 million trees were knocked over and 3 people were killed. This photo shows shattered glass in a building in Russia, the result of the famous Chelyabinsk meteorite impact in 2013, and the blast destroyed parts of other buildings as well. A meteorite hit this car in Peekskill, New York in 1992. No one was injured, but the owner of the car would definitely not have said that this was very good. These are NASA technicians working on the DART mission. The goal of the mission was to be a practice run for deflecting an object that was on a collision course with the Earth. So obviously NASA thinks asteroids and meteors are dangerous. What if this impactor had fallen on a big city in modern times? What a disaster that would have been. Now, we need to make a clarification that very good doesn't mean there was absolutely nothing potentially harmful in the entire universe. So obviously, the sun has always been potentially dangerous. If you get too close to it, you get burned. But God put plenty of distance between the Earth and the sun, and he gave the Earth a protective atmosphere and a protective magnetosphere. And of course, gravity existed before the fall, so technically Adam could have fallen out of a tree and gotten hurt, and that was not very good. Now, we don't know how God would have protected Adam from falling, but we have to assume that God did have safeguards in place. Some might say, well, couldn't God have just planned the orbits of asteroids not to hit the Earth, and then after the fall, he changed their orbits, and only then did they hit the Earth? However, there's a difference between these. The sun and gravity are essential components of the creation. They must exist, and the good they do far outweighs any potential harm. We can't live without the sun, without gravity. However, asteroids don't really have an essential role. They're not part of God's celestial calendar like the sun and the moon and the stars are, for example, as they are random events. And if they did not exist, it wouldn't cause any adverse effects on the functioning of the universe as a whole. So those who propose that asteroids and comets are part of God's good creation need to come up with plausible reasons for why this would be so. Hydroplate theory has a plausible explanation for where these things came from, which makes sense both scientifically and theologically. Third, miracles cannot be used to explain your scientific processes or to rescue your theory. So when the Bible says a miracle occurred, then it did. However, we're not free to just invoke a miracle whenever our theories run into difficulties. You must be aware that other flood models do use miracles. I'm not going to spend time going over these. If you want to investigate this, I recommend going to hydroplate.org/printable-resources, and you can find part 3 of the flood model series by Jane Albright. You can also find these on rsr.org if you just search Jane Albright in the search bar. Now we move on to hydroplate theory's assumptions about the pre-flood Earth. First, the Earth was never molten. So most creationists would agree with this assumption. If the Earth didn't evolve, we don't need any long processes of heat and gradual cooling to explain its existence. Second, the Earth may or may not have had an inner core, but definitely did not have a liquid outer core. Hydroplate theory assumes that the entire mantle was relatively cool in comparison to its current temperature. Now, the reason to think that a metal core might have been present is that satellites seem to have detected metal cores in other planets. If the inner core formed as a result of the flood, it would have happened during the days, weeks, and months after the mid-ocean ridges bulged upwards. Even a small amount of movement in the rock would have caused catastrophic melting of the mantle and the core. And during this melting, gravity might have been able to pull heavy metals like iron and nickel to the center. And the red lines kind of represent the shifting of the rock as the mantle rose. All the rock, even down to the core and to the other side of the Earth, would have shifted as well. The axis tilt was the same as it is now, 23.5 degrees. Now, this assumption is often misunderstood. Most people don't realize how difficult it is to change the axis tilt of a spinning object as large as the Earth. It's basically impossible. It's more likely that the Earth would move through its spin axis. The theory proposes that the Earth did roll, but without changing its axis tilt. The roll resulted in a change of location for the geographic North Pole. To help us understand this principle of physics, Brian Nichols set up his famous bowling ball demonstration. The red spot is the place where the lead is, so it's more dense than the rest of the ball. And you can see that the red spot can go from kind of the ball's North Pole and migrate down to the ball's equator. But the spin axis of the ball never changes. The spin axis is always perpendicular to the table. Fourth, the Earth went around the Sun in exactly 360 days. Hydroplate theory is the only flood model, to my knowledge, that makes this claim. Ancient history strongly supports this idea. Written records from many ancient cultures show their belief that the calendar was 360 days long. Sometimes they wouldn't even acknowledge that the 5 extra days existed. For example, the Romans only paid their soldiers for 360 days. One pharaoh tried out his godlike powers and commanded the year to go back to being 360 days, but of course it didn't work. For a thorough list of cultural references to a 360-day year, you can go to 360dayyear.com. Hydroplate theory also speculates that the lunar month was exactly 30 days. So before the flood, the sky was a perfect calendar, 12 months of 30 days each. But isn't this what we should expect from a perfect God who told us to use his sky as our calendar? Now, Noah and his family would have experienced 360-day years before the flood, and they passed this knowledge along to their descendants. But then as people spread out across the earth after the flood, they began to realize there was something wrong with the sky. The seasons weren't lining up with the sky calendar like they used to. So maybe structures such as Stonehenge or the pyramids, they may have been built in order to try to figure out how the post-flood sky worked. Well, hydroplate theory offers an explanation for how and why this change occurred. And the crust of the Earth was a solid, continuous shell and did not have continents like we have today. And this means no Pangaea. Now, the idea of supercontinents is a paradigm that is so hard to get rid of. It's drilled into us, and we don't even recognize it as one of our assumptions. Now, I have to admit that I read Dr. Brown's book several times before I finally realized that he had completely discarded the idea of Pangaea. I think maybe I'd heard the word supercontinent used by several hydroplate advocates when they were talking about the granite shell. Maybe that was what confused me. At any rate, the light bulb moment actually occurred while I was on the phone with Dr. Brown. I will never forget that moment. All of a sudden, I could see the big picture of how all the details of the theory fit together. So I figured that since I myself had misunderstood this for quite a while, I thought it might be helpful to make this point really clear. Hydroplate theory assumes that the Earth would have looked very different before the flood. No continents and no oceans as we know them today. But we'll mention pre-flood bodies of water in a few minutes. The crustal shell was made primarily of granite or granite-like rock, and we'll come back to this point in a few minutes. There was a layer of water under the crust, and the layer was at least 1 mile thick. Now, this assumption is not as crazy as it sounds. Scientists are now telling us that there is, quote, a vast amount of water locked up in mantle rock. However, they're not talking about liquid water, but OH molecules that are locked into mineral crystals. So it's more like potential water. If the OH molecules can find some hydrogen atoms, then they can make an H2O molecule. But the main point here is that subcrustal water isn't crazy talk anymore. I mean, they've even suggested that Mars once had water under its crust. Additionally, hot water was found at the bottom of the world's deepest holes. This was very surprising, and it proved that water can be at unexpected depths. This subcrustal layer of water is assumed to be the Great Deep that we read about in Genesis 7:11 when the fountains of the Great Deep burst open. Now, it's also assumed that the water below the crust had no contact with the surface water. This is partly due to extreme pressure inside the crustal rock. We know from lab experiments that when granite is under extreme pressure, it becomes less solid and will deform to fill cracks. So underneath depths of about 5 miles, small cracks would close up. Now, this is why scientists were so surprised to find water 7 miles beneath the surface in the super deep boreholes. Dr. Brown's estimate of how much water was under the crust was partly based on the percentage of salt found in our oceans today compared to the amount of salt found at the bottom of these boreholes. He assumed that this deep water could have been a remnant of the water that had been in the subterranean chamber, or was at least similar to it. He also assumed that about half of today's ocean water used to be in the subterranean chamber. This layer of water under the crust will provide a way for sediments to be generated very quickly and will also provide a way for continents to slide. Plate tectonic theories drastically underestimate what it takes to move a continent. The implausibility of their arguments has been pointed out since the early 1970s, but the tectonic advocates have managed to get most of the objectors canceled. But the reason they stick to their implausible ideas is because they don't have anything better. Well, hydroplate theory is providing a better idea. A layer of water under the continents would have reduced friction and allowed them to slide very quickly. The mantle was, and still is, made primarily of olivine and peridot. This assumption is held by almost all scientists, as far as I know. Olivine and peridot are silicon-based minerals like granite, but unlike granite, they're very high in iron and magnesium, which makes their lava very runny when they melt. When the lava cools, it turns into basalt. Much of the ocean floor is paved in basalt. However, no one knows for sure what the mantle is made of because we've never been able to drill down into it to get samples. Everything we know about the mantle comes from basically two sources. One is seismic data. We know how fast pressure waves travel through various types of rock, and the waves that we observe traveling through the mantle seem to match the behavior of these minerals. The other source of information comes from small unmelted chunks of rock called xenoliths, and they're found in cooled lava. This picture shows a light green xenolith made of olivine, which is embedded in a chunk of basalt. We assume that these xenoliths are pieces of the same rock that melted into the lava, but they somehow escaped the melting process. Perhaps the chunks were picked up as the lava surged past and they were just kind of carried along to the surface. And we know from lab experiments that this is true. When olivine and peridot melt, they turn into basalt. So the assumption is made that the basalt on the ocean floor came from melted mantle rock. Here's a question. Why do seismic studies show such a sharp distinction between the mantle and the crust if they've always been in contact? Where did this sharp separation come from? Why doesn't the earth just kind of gradually transition from granite to olivine? However, if they were originally separated by a layer of water, this would explain the sudden shift from crust to mantle. Now let's come back and take a closer look at the crust. First, the crustal shell was, as we said, primarily made of granite. Continental crust is essentially granitic, so this assumption isn't really controversial. Granite is made of several distinct minerals: quartz, which is usually clear or white; feldspar, can be pink, blue, green, or white; and biotite mica, which is generally black. Quartz, SiO2, is by far the dominant mineral, usually making about 70 to 75% of the granite. Secular scientists think that granite was formed as the molten earth cooled. However, if all these minerals could shift their position when they were in the molten state, then the gravity of the earth should have sorted them by density, forming layered stripes, not the speckled texture that we see in granites. Hydroplate theory asserts that granite has never been molten and is never melted. Perhaps when you are holding a piece of granite, you are touching something that is essentially unchanged since day 3. An interesting property of quartz is its ability to generate an electrical current if it's squeezed or stretched, and this property of granite will be very important when hydroplate theory tackles the topic of radioactivity. Hydroplate theory assumes the crust was at least 10 miles thick, but could have been as thick as 60 miles. Dr. Brown's first estimate was 10 miles, and then he changed to 60 when he became convinced that the newly discovered trans-Neptunian objects out at the edge of the solar system had probably come from Earth's crust. Additionally, there was also new seismic information indicating that there might be a liquid layer about 60 miles deep. Now, these numbers are educated guesses by Dr. Brown, and if they end up getting tweaked by future hydroplate researchers, this is not going to invalidate the theory. So what was on top of the granite crust? Well, we don't know for sure, but there must have been a lot of dirt on the very top so that plants could grow. How much dirt? Well, we don't know. Was there any sedimentary rock? Perhaps a little, but there was no fossil-bearing rock, since fossils, we assume, are a result of the flood. We can assume that useful minerals were on or near the surface so people could discover them and use them. The Bible tells us that people had already discovered onyx, which is a very smooth black rock with a chemistry similar to quartz. And we're also told there was gold in the pre-flood place called Havilah. Now, the presence of gold at the surface is contrary to the standard model of planet formation, where dense materials would have sunk towards the core while the Earth was molten. Hydroplate theory assumes that in some places the crust dipped down to touch the mantle, forming pillars. Now, we can't know for sure if these are the pillars that the Bible talks about in verses such as Psalm 75:3. Now, the use of the word pillar could simply be an ancient metaphor suggesting strength and dependability. Hydroplating theory does not depend on a literal interpretation of these verses. However, it is the only creation model that does provide the possibility of a literal interpretation of the word pillar. The crust had to touch the mantle in some places, otherwise the crust would have been free to spin around on the almost friction-free layer of water. Now, the number and size of pillars isn't specified by hydroplate theory. Perhaps the pillars were under seas, as this diagram shows, or perhaps they were under mountains. Again, hydroplate theory doesn't specify where the pillars were located. There were large seas on top of the crust, even seas large enough to hold many whales. Though Dr. Brown's book does not discuss this, I'd like to propose adding another initial condition to the pre-flood seas. I'd like to suggest that the bottom of these seas was covered with a very thick layer of clay, perhaps even a mile deep. Clay is used to line artificial ponds so that they'll retain water. If this works for ponds, why not for seas? If the pre-flood seas had a thick clay bottom, it becomes very easy to explain massive shale deposits that contain fossilized sea creatures. The Burgess Shale is at high elevation and contains almost nothing but bottom-dwelling sea creatures, many of them extinct. The hydroplate theory will suggest a plausible way for a clay seafloor to end up as a shale deposit on top of a mountain. We assume the oceans as we know them today did not exist, and this assumption actually sheds light on a verse in Revelation. Revelation 21, verse 1, where John says, "Then I saw a new heavens and a new earth, for the first heaven and the first earth had passed away, and there was no longer any sea." Like, why get rid of the sea? Well, the ancients didn't have the word ocean, they used the word sea. If we replace the word sea with the word ocean, the verse makes sense if we understand that our oceans were the result of the flood, and the flood was the result of God's judgment upon mankind's sin. The ancients saw the ocean as a scary and dangerous place, and actually they were right. So when God makes the new creation, he will remove all the damage that sin has done to the earth. Therefore, the Pacific Ocean will have no place in the new creation because it's the result of judgment. Of course, God will have to provide bodies of water for aquatic animals, but the oceans, as we know them today, apparently won't be incorporated into the new creation. We assume there would have been some mountains, but not nearly as high as today's mountains, perhaps mountains that were less than 10,000 feet or so. Some animals seem to be designed for living in mountain habitats, so God may well have created mountainous areas. The fact that there were no mountains as tall as those that we have today helps to explain why the floodwaters could cover all the mountains. Mount Everest and the Himalayas just didn't exist yet. A few assumptions about the moon. First, the moon was originally smooth and white and didn't have the gray splotches that we call maria. Astronomers think the maria and craters were made by rocks or asteroids that hit the moon, and the craters give clues that leads astronomers to think that they happened in clusters, not as random individual events spaced evenly out over time. Hydroplate theory asserts that the rocks that hit the moon came from the Earth as a result of the flood, and if this is correct, then the craters weren't there before the flood. We assume the moon's orbit around the Earth was a perfect 30 days, like we've mentioned. Hydroplate theory asserts that rocks and water were ejected from the Earth, and some of it hit the moon. But how much would have to have hit the moon to affect its orbit? This chart is a summary of Dr. Brown's calculations. Based on his estimates of the volume of ejecta, it turns out that only a little over 1% of the ejected mass would have had to hit the moon in order to change the lunar month from 30 days to 29.5 days. Therefore, this assumption is entirely reasonable. The moon would have rotated so that people would be able to see both front and back sides. Today, only one side of the moon faces Earth. Astronomers think the reason this is true is because of a shift in mass that happened at some point, and the near side experienced an increase in mass, and then gravity has pulled it preferentially, locking it into position. So before the flood, we would have been able to see all sides of the moon. The moon might have driven Earth's hydrological cycle. So if this is true, there might not have been any rain before the flood. The Earth-Moon tidal system could have driven a hydrological cycle quite unlike anything we can imagine today. The Bible says a mist or streams rose up from the earth and watered the surface of the ground. So if there was no rain before the flood, this would help to explain why it was so remarkable to see a rainbow in the sky after the flood. If it had never rained, no one would ever have seen a rainbow in the sky. In a waterfall maybe, but not in the sky. We need to note here that other flood theories run into trouble when trying to explain how it could have rained for 40 days straight. Today's hydrological cycle can't possibly produce 40 days of torrential rain nonstop. And this becomes a reason for secular scientists to doubt that the flood was truly global. Only hydroplate theory can provide a massive source of water and a plausible mechanism for getting it into the sky. The moon may have been designed to be a part of an energy harvesting system that could provide gentle geothermal heat. The gravity between the moon and the earth caused the crust to bulge outward towards the moon twice a day as the earth rotated. The tidal action would have caused the crust to flex, which caused a thermal reaction generating heat in the crust and in the water. But we'll discuss the heat momentarily. Finally, a closer look at the Great Deep. Hydroplate theory assumes that the water was under extreme pressure, possibly up to 372,000 psi. I have to point out that some hydroplate advocates are a bit uncomfortable with this extreme pressure being part of the original design before the fall. There's concern that this would have set up an inevitable failure of the crust, even without the effects of the fall. We'll come back to this objection at the end of the section. This pressure would have led to extreme heat. Now, Dr. Brown's PhD is in heat transfer, which is a specialty topic of mechanical engineering. So he was able to do all the math involved in figuring out how much heat this scenario would have put into the water. The pressure in the subterranean chamber could have raised the temperature to well above 374 centigrade, possibly as high as 700 centigrade. And under these conditions, water becomes supercritical. Supercritical is like a fourth state of matter above gas. This phase diagram can help us to understand what supercritical water is. So the yellow dot represents water at 32 degrees Fahrenheit, which is the freezing point, and at 14.7 pounds per square inch, which is regular atmospheric pressure. So you can see that at regular atmospheric pressure and the freezing point, water sits on the line between solid and liquid. In this diagram, the yellow dot shows you what water is like at 372,000 psi and somewhere between 32 and 212 degrees Fahrenheit. So more than freezing, but less than boiling. And it's still liquid when it's in these conditions. However, if you raise the temperature and the pressure, now the yellow dot is up in this area called supercritical. So it's not water, it's not vapor, and yet it's kind of both at the same time. So supercritical water is made of incredibly small droplets, maybe only 5 to 10 water molecules large. And this is much smaller than droplets in steam. And the droplets are constantly falling apart and reforming. This diagram shows supercritical water as a mix of individual water molecules and these very tiny droplets. Now, the total surface area created by the droplets is very large, and this will allow for rapid cooling. An everyday example of how surface area affects cooling is to think of peas and potatoes. The pile of peas on your plate cools much faster than your baked potato because of surface area. So this large amount of surface area in supercritical water means that it can both expand rapidly and cool very rapidly. Later in the theory, this rapid expansion and cooling will become very important. Hydroplate theory assumes that there was dissolved carbon dioxide in the water as well. This assumption is not unreasonable because carbon dioxide has been found dissolved in the water at the bottom of the world's deepest boreholes. So this assumption is actually proven fact. Supercritical water is really good at dissolving things. Supercritical fluids are studied in labs, so we know quite a bit about them. They're used as industrial solvents. So here we see a tiny supercritical water droplet dissolving away a few molecules of rock. The waters of the Great Deep would have had a lot of dissolved minerals in them because of this action of supercritical water. And mineral atoms in the water would have been free to recombine in new ways, forming new molecules. So they would be free to combine and form things like CaCO3, which will turn into limestone, NaCl, which can make salt, SiO4, which is quartz, Al2O3, which is aluminum oxides, and also magnesium carbonates and other things as well. The minerals would have precipitated out and blanketed the floor of the chamber. Now we know that mineral molecules can fall out of supercritical water because this has been witnessed in lab experiments. Scientists call this outsalting, and they've watched this happen in real time. It looks like little flecks of white salt suddenly appear out of nowhere and then float to the bottom of the container. As a result, we can speculate that there would have been quite a pile of mineral flakes on the chamber floor by the time of the flood. The bottom of the crust might have ended up as a honeycomb texture, with gaps extending up to even as much as a mile into the bottom of the crust. However, this did not jeopardize the strength of the crust overall. What it did do was allow for the bottom of the crust to have a lot more surface area, and greater surface area meant a greater ability to absorb heat from the water. The heat could have radiated up into the crust, and by the time the heat reached the surface, it was no longer super hot, just a mild, gentle heat. Sometimes ice will create a honeycomb pattern as it melts. This photo shows ice in Antarctica being dissolved by wind. Now, Dr. Brown asserts that this high pressure, high temperature situation would have eventually reached an equilibrium and become stable. Others have suggested perhaps maybe it was created already at equilibrium and just needed to maintain it. So this could be a question for continued study in the future. Now, was the Earth a ticking time bomb? Because hydroplate theory asserts that the flood was started by the opening of a crack in the granite shell, critics have suggested that hydroplate theory's initial conditions are such that the crust was doomed to crack, given enough time, and that the Earth was created as a ticking time bomb that would eventually blow up at some point. But we know that God is both good and wise, and we can safely assume that the Earth was not created as a ticking time bomb. This presentation has assumed that the crust was designed in such a way that the heat created in the subterranean chamber was adequately dissipated so that heating to the point of rupture would not have happened. This leaves us with the question of why a crack opened up in the granite shell. The answer is, we simply do not know. Some hydroplate advocates prefer to assume that God's original plan was to have the water stay cool and not go supercritical, and that only after the fall did the temperature rise. This idea leads to the conclusion that the supercritical temperatures were what caused the crust to burst open, but we simply don't know. But we can be sure that at the end of creation week, the Earth was perfect and was not at that point headed for disaster. One of the profound theological implications of hydroplate theory is that the flood really was a judgment upon all of humanity, not just the people who drowned outside the ark. If hydroplate theory is reasonably correct, then every earthquake, volcano, hurricane, tsunami, drought, and thunderstorm can be traced back to the flood. So even today, thousands of years later, Humanity as a whole is still experiencing the judgment of God against sin. The flood really was a judgment for all time, and almost no one has escaped its effects.